Hello everyone, today we will discuss about the Coulomb's law, and we already know that like charges repel each other and unlike charges attract each other. But how can we quantify this force? And that's what we can understand by Coulomb's law. Let us suppose we have two charges Q1 and Q2 separated by some distance r and placed in vacuum. So according to Coulomb's law, the force between two point charge is directly proportional to the product of charges and inversely proportional to the square of distance between them. So we can write Coulomb's law as F equal to K Q1 Q2 upon R square, where K is equal to 1 upon 4 pi epsilon naught, and which is numerically equal to 9 into 10 to the power 9 Newton meter square Coulomb square. In order to understand better the Coulomb's law, we should learn its other important aspects also. Like Coulomb's law is a central force. Coulomb's law is a central force. It means the force on one charge is due to another charge is always lies along the line joining the two charges. Coulomb's law says that the force between two charges is an action-reaction pair and conservative in nature. It means the work done against this force field is independent of path. It is valid for point charges. Actually, this is not an absolute concept. If the size of an object is very small as compared to the separation between them, so that they can be treated as point charges. Coulomb's law is not valid for distances less than atomic radius. And if the charges are present in vacuum, then the Coulomb's law takes the form F equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And if the charges are present in some other medium, then epsilon naught is replaced by permittivity of given medium. Since the permittivity of given medium is greater than the epsilon naught, then the force between the two charges in medium other than in vacuum is always less than that in vacuum. It is reduced by a factor of relative permittivity of medium, and we may understand the permittivity as a property of medium which determines how the force between the two charges get affected, or how strongly a medium is influenced by external electric field. For example, the relative permittivity for water is equal to 80. Then the force between the 2 point charges kept in water get reduced by 80 times the force between the point charges separated by the same distance. When kept in air. And a very interesting fact is, when common salt NaCl is taken in water, the electrostatic force between the Na and Cl ion is reduced due to the high relative permittivity of water, and this is the reason why water acts as a good solvent. By the way, Coulomb's law has the same structure as the Newton's law of gravitation. Both are inversely proportional to the square of distance between the particles. Means the both follow the inverse square law. The electrostatic force is directly proportional to the product of magnitude of 2 point charges, and the gravitational force is directly proportional to the product of two masses. But there are some important differences also between these two laws. Like gravitational force is always attractive, but electrostatic force may be attractive or repulsive, depend on the sign of charges. It is because the mass only lies in, or mass is only of as a one kind, no negative or positive mass, but charges as of two types, like positive or negative charge. So the same sign, same charges repel each other, opposite charges, opposite sign attract each other. The gravitational force between the two masses is independent of medium. But the electrostatic force between the two charges depends on the nature of the medium in which the two charges are kept at rest. The electrostatic force constant is much larger than the gravitational constant. So that's what we have discussed about the Coulomb's law, and I hope you understand better the Coulomb's law. In case if you have any query, please write in the comment section, and thank you for watching. Thanks a lot.